Quadratic equations, functions, zeros, and models. These are the topics we're going to discuss here. First of all, we try to find the zeros of quadratic function and solve quadratic equation by using the principle of zero product property, by using the principle of square root and completing the square, and finally the quadratic formula. And finally, we're going to see some application problem. Quadratic equation, whenever you see an equation in this form, that's called quadratic equation. This is called quadratic because, as you can see here, the degree of x, the exponent on the x, the highest one is 2. That's why it's called quadratic. And this form is in the standard form. So here a, b, and c, they are some real number. Keep in mind, a cannot be equal to 0 because if a is 0, then this quadratic becomes linear. Here for a, you can choose any real number except 0. Let's say 5. For b, you can choose any real number. For c, you can choose any real number. That's how you can get quadratic equation. If you name this part as a function, then that is called quadratic function. And the zeros of the quadratic function means the value of x which make this function 0, which make this equation 0. That's called zero of quadratic function. So when we solve quadratic equation, our equation might have real solution, or maybe it has imaginary solution. So when solving quadratic equation, we might need zero product property. So for example, let's say you have x squared plus 2x plus 1 equals 0. Then after finding the factors, let's say x plus 1 and x plus 1, these are the two factors for x squared plus 2x plus 1. If you multiply them, this is what you are going to get. Now the product of them is 0, so according to the zero product property, at least one of them, in this case it's the same, supposed to be 0. That's called zero product property. And now you can solve x equal -1. Principle of zero product property. Square root property means, let's say if you have x squared equal 4, you are thinking of for what value of x whose square is 4. And there are two options. One is square root of 4, and another one is negative of square root of 4. For both of them, the square is supposed to be 4. So square root of 4 means 2. It's -2. So this is also a useful principle to solve quadratic equation. And sometime to use this square root property, you have to complete the square to solve quadratic equation. For example, let's say here's the quadratic equation, x squared, okay, plus 2x equal 0. Let's say this is the equation we would like to solve using this, what is this called? This is a square root property. So we need to complete this square here on the left side because there is no square, one square. And how do you do that? Isolate the terms with the variable on one side, so meaning all the x's goes on the left side and all the numbers only goes on the right side. In this problem there are no numbers, so just the x terms. Divide by the coefficient of a square term if that coefficient is not 1. Here the coefficient of x squared is 1, so you don't have to divide. Complete the square by taking half the coefficient of first degree term. So you can complete the square by taking half of this x coefficient, which is half of 2 is 1. So you want to add 1 both sides. Complete the square by taking half the coefficient of the first degree term and adding its square. So I'm adding the square on both sides. Square of 1 is 1. So by doing this, what happens is the term, you see this three terms, that always gives you the square of the first one, which is x, and the last one, which is 1, and the middle one is just the sign coming from the middle one, which is plus. This is equal to 1. Now, if this is square of this expression is equal to 1, then this expression x plus 1 is supposed to be either square root of 1 or negative of square root of 1. Square root of 1 is 1 itself, and negative of square root of 1 is negative 1. If you subtract 1, x would be 0, and here if you subtract 1, x would be negative 2. So these are the two solutions of this equation, which we can solve using the this completing the square process. There is one more way to solve quadratic equation by using the formula. This is the formula x equal negative b plus minus. Plus minus means it gives you two values, one with the plus and one with the minus. So when you calculate the value, you have to choose plus first and then minus, and then in that way you might be able to find two different answers. Okay, the expression b square minus 4ac in the formula you can see here, based on the value of this expression, if it's exactly equal to 0, then the solution for the quadratic equation would be only one real number. If this expression is positive, there will be two real number solution. And if this expression is negative, there will be two imaginary number or complex conjugate solution. So based on the value of this expression, which is also called discriminant, you will be able to say how many zeros you have. Sometimes we can reduce an equation into the quadratic equation. For example, this one, this is the fourth degree equation, but what we can do is let's replace x squared by some another variable u. If you do that, this problem becomes u square, because u means x squared. So x to the power 4 is square of the square, and which is u square, minus 5 times u plus 4 equals 0. So look, this is the fourth degree equation, but we can reduce it to the quadratic equation for u, not for the x, for u. So if you know how to solve quadratic equation, you might be able to solve this equation which is higher degree than quadratic. So let's look at some homework problems. Find the zeros of the linear function. Zero means for what value of x this function would be 0. For x equal negative 5, negative 5 plus 5 is 0. So that's the 0 of this function. Okay, use the graph to find each of the following, the zeros of the function. 0 means where the graph intersects the x-axis, which is in this case 1, 2, 3. 1, 2, 3, negative 3. So what is the 0 of the function? Negative 3, because at negative 3 the function, the y is 0. What is the x-intercept? The zeros of the function and then x-intercept, they might be same, but you need to write down in the order pair form, so which is 0 comma negative 3. This 0 is for, sorry, that's wrong, it's a negative 3 comma 0. This 0 is for the value of the function, which is the value of y. Use the quadratic formula to find the exact solution of the following equation. This time we are asked to use this formula. So let me we're asked to use the formula, quadratic formula. So I'm going to write down the formula here, which is x squared The formula is, if you have quadratic equation ax square plus bx plus c equals 0, then solution of this equation is x equal negative b plus and minus square root of b square minus 4 times a times c divided by 2 times a. So in this case, the problem we have given is x square minus 9x. We have to bring that 22 to the left side by subtracting 22 from both sides. By doing that, you can see, you can compare the equation, and the number in front of x square is the value of a. In this case, there is nothing, so you can always put 1. The value of b is number in front of x, which is in this case negative 9, and c is the constant, which is negative 22. So if you want to use this formula, so the value of x is negative v, which is negative 9, minus and plus square of the b, which is negative 9 square, is 81, minus 4 times a times c, which is negative 22, divided by 2 times a. A is 1, so it doesn't matter. So we have to simplify this here. So this is negative times negative is positive, plus and minus. This is 81 plus 88. Good. Divided by 2, which is 9 plus 81, 161, 169. Divided by 2. 81 plus 88 is 168. 81 plus 88 is 169. And then the square root of 169 is 13. So this is 9 plus or minus 13 divided by 2. So now to find the value of the solution, first you use the plus and then you can use the minus. So x is 9 plus 13 divided by 2. That's the one solution. And another solution is 9 minus 13 divided by 2. So here 9 plus 13 is 22 divided by 2 is 11. Here this is negative 2 divided by 2 is negative 1. So these are the two solutions, 11 and negative 1. Simplify your answer and then type exact answer using radical as needed. Use comma to separate the answer. What happened? What did I do wrong? Negative 1. Yeah, I did something wrong here. 9 minus 13 is 11. Okay, let me go back here and check one more time. A is 1, B is negative 9, C is negative 22. So negative B plus minus, minus is plus. B square, which is 81, minus 4 times A times C. 22 times 4 is 88. 9, 69. 9 plus minus 13 plus 9 is 22 divided by 2 is 11. 9 minus 13 is minus 4. Okay, that's the wrong. This is minus 4. This is not minus 2. So that would be minus 2. So it's a minus 11 and minus, sorry, plus 11 and minus 2. So my mistake was subtracting, okay. 9 minus 13 is minus 4, not the minus 2. That was the mistake I did here. Find, give exact and approximate solution. The exact solution are, you can use the one of the, method like using quadratic formula or factors or, to completing the square formula to solve this type of quadratic equation. Okay. Find the zeros of the function algebraically. So meaning you have a function f of x. F of x is 5x squared minus x plus 8. The zeros of this function means find the value of x for which this function is 0. Meaning you are trying to solve this equation. How can you solve it? You can use a quadratic formula one more time. So the quadratic formula is negative. So here a is 5, b is -1, and c is 8. So the formula is negative b plus minus square root b square minus 4ac divided by 2a. Negative b is -1, so it would be eventually positive 1. It's a 1 minus 4 times 5 times 8 divided by 2 times a. Okay, so this is 1 plus minus, and this is the negative value, 160. So it's a negative 159, I guess. 160 minus 1 plus negative 160 plus 1 is negative 159 divided by 10. So this is imaginary number. The solution is supposed to be imaginary number. The zeros are, as you can see here, they are asking us to use radical and I as needed. So 159, is it something we can factor out? 159, which is 3 times 5, 3, and there is nothing else we can do. So this is 1 plus minus square root of 159 times square root of -1 divided by 10. It's a 1 plus minus square root of 159i divided by 10. So how do you write it? You can write 1 over 10 plus square root of 159i. That's the one solution. The another solution is 1 over 10 minus, sorry, you have to divide this by 10. Square root of 159 divided by 10 I. So these are the two solutions. Okay, 1 over 10, I think that's 1 over 10, and square root of 159 divided by 10. Before that you have negative sign, sorry, minus, and there is a I. There is a I here. So that's one of the solution, comma. Another solution is 1 over 10 for sure. 1 over 10 plus, again it's a square root 159 divided by 10, and there is one more I here. So these are the two solutions using the quadratic formula. Find the zeros of the function. This is the same thing. Okay, this is one of the application problem. After declining between 1940 and 1980, so it's going down from 1940 to 1980. After declining for the 40 years, okay, look at here. After declining between 1940 to 1980, the number of multi-generational households has been increasing since 1980. The function, the household number of household is in the form of quadratic function 0.012x squared minus 0.583x plus 35.722. This is a quadratic function. Can be used to estimate the number of monthly generous household in country A in millions, X years after 1940. In what year were there 40 million monthly generous household? So you need to find out the time when the number of household is 40 million. So that means this function is 40 million. So you need to put this function equal 40. So remember, there is a decimal. So to make it easy, I'm going to multiply all these both side by 1000, because after decimal there are three numbers. So if you do multiply by 1000, there will be no more decimal. So multiply both side by 1000, that becomes 12x squared. Here it will become 583, because after decimal there are three digits. So 583x, and it would be 35,722, and that's a 40,000. You have to bring this to the other side so that you can make it like a quadratic equation. Okay, 583x minus, so just subtract 35 and then 722 minus 40,000. That is 4,278 minus. So 4,278. Let me try if I can divide this by 12. Oh, it's in decimal form. I don't want to do that. Okay, divide by 3. Can I divide this by 3? Okay. Can I divide 583 divided by 3? No. Okay, so this is the quadratic equation we need to solve for finding the time where the number of household would be 40 million. So quadratic formula can be used. So what is the quadratic formula? 12x squared minus 583x minus 4278. 4278. This is A, this is B, and this is C. So x is negative b, negative times negative is positive, plus or minus square root b square. So 583 minus square minus 4. A means 12. C has a negative sign. This negative and this negative becomes positive. So times 4278. Divide by 2 times A, which is 24, because A is 12. So we just need a calculator to do this calculation here. So 583 square is 339,889. So it would be 583 plus minus 339,889. 889 plus, you multiply this to number, which is 4 times 12 times 4278. That is the 205,000. 205,003 and 44 divided by 24. So I'm going to add this to number, plus 339,889, and I'm going to take the square root of that, which is in decimal. That is fine, 738. So 583 and then decimal. If you use the negative sign, the answer, the x, which is the time, would be negative, which is not possible. So the only way we can make it possible is by just using plus sign. So this number plus 583, divide that by 24, and that is the 55.058. Round to the nearest whole number. So it is 55 is the whole number in 55. So look at here. So this model is starting from 1940. So after 55 years of 1940 would be 1995. So 1995 is the answer. There were 40 million multi-generation households in 1995 because that is 55 years after 1994. So that is the type of the question we can answer using the quadratic equation, quadratic formula. And that's all for this section.